Welcome to the Control Engineering webcast, Drastically Improve OEE and Quality with Advanced Analytics, sponsored by GE Digital. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with the audio or the slide presentation, click on the question mark at the top corner of the screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Pick the questions for our speaker in the Ask a Question box on the left side of the screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of the screen. Those documents will also be available with the on-demand version of the webcast. After today's webcast, those who have attended live will be eligible to be part of a drawing to win a $100 Amazon gift card. The winner will be contacted by CFE Media later this week. Now we will hear from the sponsor of today's webcast, GE Digital. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned after the video for today's presentation.
What the world needs now is people. People who see things just a little bit differently, who go out of their way to find a new perspective and a new way forward. Because seeing a smarter, healthier, cleaner world isn't something that's far in the future. It's something we're building now. GE, building a world that works.
I'm happy to introduce today's distinguished presenters, Cobus van Heerden and Gregory Dunn. Greg will be joining us for the Q&A session at the end of Cobus's presentation. Greg is the product manager for manufacturing solutions at GE Digital. In his role, he focuses on cloud-based manufacturing software, helping customers to deploy faster and with lower total cost of ownership compared to traditional solutions. With more than 20 years' experience in the industrial software space, Greg has served in product management, software development, and leadership roles. He holds a Bachelor of Science in Computer Science from the University of Victoria. Cobus van Heerden is Senior Product Manager for Analytics and Machine Learning Software for GE Digital. Cobus has 20 years of experience in developing and implementing industrial software globally. He specializes in helping industrial organizations realize transformational productivity gains through applying digital technology, advanced analytics, and machine learning. Thank you for joining us today, Cobus. And please go ahead.
Hello, everyone, and thank you very much, Mark, for that introduction. It is fantastic to be with you today and to spend this hour talking about how manufacturing companies can improve overall equipment effectiveness, also otherwise known as OEE, using analytics. So like Mark introduced, I work for GE Digital. GE Digital is one of 5 GE companies, General Electric companies. And in GE Digital, we focus on helping industry with industrial software solutions. Within GE Digital, I'm part of the manufacturing business where we help manufacturing customers for more than 30 years with industrial software solutions. Last year, we asked our customers a question. We asked them what would be some of their toughest challenges today and their priorities. And, you know, as the number one priority from our customers came productivity, the need that they have to maximize and improve the productivity of their manufacturing plants. So with that in mind, let us just look for a moment at the industrial software landscape. On the left, you see the traditional view that has been around for a long time, where, you know, at the very bottom, you have to, you know, you have the equipment of the plant and physical sensors. Then you have the automation layer of your PLC controls, where you automate the equipment, above which there's your SCADA or your supervisory control and data acquisition system that really monitors and operates and controls the plant and provides the user interface to your automation, above which there's the manufacturing execution systems, which provide more contextual operational data and also really help to automate operations and operate the processes, and above which there is the ERP or enterprise resource planning layer. That has been the traditional view for many years. That has evolved over, you know, the last number of years to a view that we can really simplify, like the view on the right, to a variety of operational software systems on a plant level, you know, including all the operational software that's required to really operate your manufacturing facilities, including your SCADAs, your MESs, you know, industrial data management software like process historians, your EBR or enterprise electronic batch records, quality management, your work process management, and also scheduling software. So variety of different operational software on the plant level that really produces data and that operates and really automate the operation, facilitate the operations on a plant level. All of these systems produce data that are generally centralized on a enterprise or sort of multi-plant level, either in central data centers or, you know, in public clouds. And on this enterprise level, a variety of enterprise applications resides that look more across plants, at visibility and metrics, at supply chain related management, etc. On a plant level, most manufacturing operations and manufacturing companies these days start to measure and track their efficiency, their performance, and most often using overall equipment effectiveness, or OEE, as one of those metrics for measuring and evaluating and tracking the efficiency and performance of their plants. And then most recently, analytics software became available that can now be used based on the data that all these operational systems provide to help manufacturing plants, and either on the plant level or also on the enterprise level, optimize or improve their operations and their efficiencies. So the question of today's talk, how can manufacturing companies improve OEE using analytics? And the good news is that manufacturing organizations have the opportunity to really take their performance to the next level by applying analytics to their operational data to improve the efficiency of their facilities. As we know, your operational software, traditional operational software like your SCADAs, your MESs, they are really focused on operating your plants. and facilitating production, managing and monitoring of production processes, while analytics software is really focused on process optimization. How can we improve the efficiency of manufacturing operations using the data that these operational software systems provide? The information typically from your MES systems are descriptive in nature. So for example, your MES, often OEE as efficiency metrics are calculated using a MES software solution. It doesn't necessarily have to. Sometimes, vendors like GE Digital provide lightweight OEE solutions to just calculate and track OEE. But that information is descriptive in the sense that it measures your efficiency. It does not necessarily improve it or tell you how to improve it. That is the role of analytics software that can help you move to become prescriptive in knowing how to improve your efficiency. So, typically the metric OEE is a combination of the availability of your equipment, the speed or throughput, the rate at which you are producing, as well as the quality of the production that you are generating. And so these three elements, manufacturers can get significant improvements in all of those elements by applying analytics, by using analytics to combine operational data and really then, use it to optimize these three elements of OEE. But let's take a closer look at overall equipment effectiveness, the measure of OEE. As you can see, it consists out of three components. Generally, software solutions exist that calculate and measure and therefore track over time, benchmark your the OEE of your plant or factory. And because it's a standardized metric, you can compare that with your other plants if you are in a manufacturing enterprise. And you can compare it with industry peers, and there are standards, for example, that say 85% is world class, and often, plants 60% may even be typical. So it's comparable, and you can benchmark it within the enterprise, but also with in industry with your peers. But it consists really out of availability, which is what portion of the fully planned production time that was scheduled or planned for have the equipment actually been producing or running. That is what availability is. So in other words, your fully planned or scheduled production time minus, or if you take away the portion where you had unplanned or unexpected downtime, then what remains really is the time where the equipment was actually operating. That is your availability. And from that time where the equipment was operating, then the next component is the performance or the speed at which you were producing. Your equipment may have the capacity to produce, let's say, at 100%, but you may only have been running at 90% for your operating time. That means you were running, but only at 90%. So 90% of your capacity, that is your performance factor. You've not been utilizing your full capacity during production time. And then lastly, there's the quality component where, you may have been producing, but a certain portion of your production may have been bad quality, which means that if you look at the time that you were actually running, combined with, what percentage of your full production capacity you were producing at, combined with how much of that was actually good quality product, that gives you overall equipment effectiveness. And as you can see, the inefficiencies or the losses are due to unplanned downtime while you were supposed to be producing, or capacity or speed loss while you were not utilizing your full capacity, or quality loss when you were trying to produce, but you were producing bad quality product. And so what analytics can help you do is to really zoom in to your, OEE for plants or components in the plants where it is low, to understand why is it low and how can it be improved. So within the analytics journey, analytics, this is a quite well known by now, a big data analytics framework or maturity model by the research firm L&S that really just talks about the different types of analytics or information and how it can be used. So for example, on the bottom left, you see descriptive analytics or descriptive information. And we said that your typical MES systems, or the software that calculates OEE, the OEE statistic or metric in itself is of a descriptive nature. It's telling you how you are performing, how efficient you are performing. And you may be, logging and storing all your production data in, for example, a process historian or in historians. You may, but that information, is at best diagnostic, meaning, your MES system may go as far as to give you some operator-logged reasons for why you had downtime. Or you may have some trending tools in your historian. But what analytics can do, apply to all the operational data, is really become really diagnostic in determining why was the OEE of a specific plant or line low? And if you see the quality was the low component, why were you producing bad quality products? So answer all those why questions to gain insight. And then also analytics can help you to predict, to become predictive. So determine if you continue as you are, what will likely happen? When may you have a high risk for downtime next? Or you can predict quality. What will likely be the quality of this batch? And so you don't have to wait for a lab sample, for example. Or, what is likely the risk of a reduction in speed loss on a specific unit. So you can become predictive. And ultimately, the destination or the goal is to utilize analytics to become prescriptive. In other words, to use the analytics to work out what is the best settings or way to run my equipment, given the current conditions, to have the best possible OEE, so to strive for 100%. So if you are currently at 85% efficiency or OEE in your factories, what to strive for that remaining 15%. And that can, analytics can help you get closer to that 100%. So if we are talking about using analytics to optimize or to improve OEE and to optimize manufacturing plants, we have to pause for a moment and think about manufacturing data strategies and data management. It is so important. So in modern manufacturing organizations, you may have multiple plants, and data is generated, lots of data, operational data, sensor data, quality data, maintenance data, raw material data, across the whole value chain, data is generated. And just to think about how to manage that data, where to store the data, for example, so that it is available not only to analytics, but to operational applications and, in order to manage, but also improve your operations. And when you think about data strategies, then, keep in mind, you have to think around criteria like regulatory control. So, ask yourself, okay, a specific type of data, do I need it for regulatory purposes? If so, yes, where? For how long? Is the data critical? to operations, critical to decision making. In what time frame? Do I need real-time access? You know, minute by minute, second by second, maybe for closed loop operations, automated operations? Or is this more data that I use for analysis after the effect and it's not time critical? So what are the decision horizons for which I need the data? And also, how long do I need it? Do I need it long term or just short term? So these will help you think about how and where to store data, at what resolution, at the most effective cost, so that, you know, analytic solutions, for example, can utilize it effectively to also optimize the efficiency of your plant. And this may be a combination of storing, you know, for example, high resolution sensor and other data on premise in process historians, for example, or storing some other data that's only needed sort of on a more after the effect, on a longer term basis, less critical in the cloud or in a central enterprise environment, if that, you know, is more appropriate. And I think the same consideration should be given to analytics. So as a capability, analytics, it's necessary also when you deploy analytics to optimize manufacturing processes, to think, where should these analytics run? Where should they be utilized? And typically, you know, analytics solutions also for optimizing plant performance, you know, can be on premise, but or it can be in the cloud. And it's not one or the other. They have different functions. The same with visibility. You know, a big part of giving, you know, digitizing and maximizing production is enabling your personnel in the manufacturing plants with visibility on the data. So visibility analytics solutions typically, you know, is on premise if it is critical for production, critical for operations, typically plant level or real time or closed loop analytics. So analytics that are acting on data, but that needs to raise maybe in real-time alerts or change set points in the process in closed loop that are used for real-time decision making. Those sorts of analytics are best suited on premise. Also, for example, in-plant scheduling and other plant-based sort of systems. And then, you know, solutions and analytics that are best suited for cloud are generally non-critical capabilities or that are non-real-time. You know, for example, analytics that have more enterprise function that need to look across plants, you know, to compare plants with one another, etc. For example, enterprise-wide KPIs or reporting or production data orchestration systems. These are suitable for cloud deployment. With that context, let's now zoom in closer to how can manufacturing organizations optimize OEE using analytics. Well, firstly, let's just ask ourselves the question, why does it even matter? What is the value of this? Why is it valuable? Why would we like to do that? Well, firstly, you know, I mentioned that generally speaking, the first step is that organizations need to measure and calculate and track OEE. And that is often done in various ways, but often within an MES system. But if you don't have an MES system, it's also not always necessary to absolutely implement the full MES solution. Vendors like GE Digital also offer lightweight OEE solutions that is just there for the purpose of helping you start to track your efficiency and calculate it. Because it is said you cannot improve what you don't measure. So the first step is, are you measuring and tracking OEE? If you are, the good news is you can use that data and apply analytics to it to start to optimize the OEE. So the first question would be, go and look at your plant. If you have only one plant or across the plants, where are the plants or the lines production lines or machines that have low OEE, where there's the biggest potential business value for improving OEE. So, obviously lines that are already running at 90%, okay, you only have 8% to gain, but lines that are running maybe at 70 or a plant maybe running at 60%, there is a lot of room for improvement. But, you guys as the experts in your plants, you will know what is the value, where's the potential for improvement, and what will be the value of 10% OEE improvement in a plant. That's the business case. So think about the value. Where is the value for improvement? Once you've identified the areas, the plants, the lines, the machines, where there's the biggest value for improvement, identify the data that you have available. So utilize the available operational data that may be in your MES system. Firstly, it will be your OEE data that shows what is the OEE for different periods for a different product on a different line or plant or machine. And then combine that with other available data across the value chain, from maybe your raw material quality data, with your sensor data, in your process historian, with your OEE or operational data in your MES, all the way to maybe your final product quality data in your quality system or in your ERP system. So data that will describe not only all the components of OEE, from quality to speed or throughput performance to availability. Combine that together so you have a data set or data sources that describe all the way from raw materials to final product, all the context needed of how this product was produced. Then apply analytics to that data to determine, firstly, the causes of low OEE, to gain insight as to why was the OEE low, and then to determine what would be the best, maybe process settings, maybe what's the best recipe settings for given set of raw materials under given situations that will maximize OEE. And then maybe it is uptime, maybe you need to avoid downtime, or maybe you need to improve quality and or run at maximum speed. But what would be the settings in the plant that will avoid the low OEE and maximize OEE for that product on that line under those circumstances? Okay, so the steps to optimizing OEE with analytics is really to look at your available operational data. Then, the good news is that analytic solutions like that which GE Digital provide and other vendors may have the ability to access data from across this value chain. So from raw materials to process historians to your MES OEE data, all the way to final product quality. Combine that data together, format and prepare it easily so you can apply analytics to it, to firstly gain insight, to answer all your why questions. Why was my quality low? Why do we have a lot of variability in our OEE? One day it's high, one day it's low. Why, do we have a lot of specific unplanned downtime every third hour of the day on that machine? And in that way, it can determine all your available data, use analytics to combine that data together in context, prepare it for analysis, or to then gain rapid insight from it using analytics to determine the causes of the low OEE and how you can improve it. So the good news is that analytic software is available that can help manufacturing plants really optimize OEE. And also, often if OEE is the performance metric, then you may have low OEE, but another challenge can be variability in OEE. So your performance may not be consistent. It may be one day a high efficiency, another day a low efficiency. So variability in performance and in throughput, in quality, in efficiency is really expensive for manufacturing plants because that just makes you less competitive. So analytics can be used to can be applied to your combined data across the value chain to help you continuously improve and optimize OEE, and so improve throughput, quality, and efficiency continuously, and have more consistently operate at improved efficiencies in your manufacturing plants. The value that is so delivered really is delivered in sort of three dimensions. Firstly, the analytics can help you gain really quick insight as to the reasons for low OEE or variation in OEE performance. So answer all those why questions. Why is my quality low? Why does my OEE vary a lot? Why do I always have downtime? So use analytics to analyze your available data to gain rapid insight as to the root causes of low efficiency and how you can improve efficiency. Secondly, deploy analytic solutions to really monitor your manufacturing processes, your equipment. Also, if you are a manufacturer that has lots of PID control loops, monitor your process, your equipment, your control loops, monitor the operations so you can early detect upsets. And analytic solutions can be configured to monitor and provide earlier detection than traditional PLC or SCADA alarm systems can. So there you can gain earlier insight of deviations, which can help you also minimize variation and stabilize your performance because you can react quicker. And also with analytic solutions, you can configure predictive analytics that can help you predict or anticipate what the quality will be at the end of the batch, or what is the risk for downtime or a next speed loss event, so you can avoid it before it happens. And lastly, once you've gained insight on causes of low efficiency, you've stabilized your efficiency, you can really maximize it to really utilize, get closer to that 100%, consistently 100% or maximum efficiency by ensuring you avoid downtime, you run at maximum production capacity when you run, and you always produce consistently good quality product. So gain insight, understand OEE variation, stabilize OEE variation, and then optimize or maximize OEE through a optimization capabilities of analytics. In this way, manufacturing, if you consider that very typically manufacturers can have as low as 60% OEE in manufacturing plants, but 85% is considered world-class, then often with analytics, by combining your data across the value chain, applying easy to use the right analytic solutions, empowering your people with the right analytic solutions applied to that data, you can improve productivity and efficiency by up to 10%. What would be the value of 10% improvement in OEE in your manufacturing plant? So let's look at two examples now of how customers, manufacturing plants have done this, exactly this. The first case study is really a food producing company who wanted to utilize their available MES data. So they had invested in implementing a MES system They were tracking and their OEE for a long time, but they also had, sensor data available in a process historian and raw materials data available, and all the way to final product quality data available. And they wanted to use their MES data combined with all of these data to really see, can they optimize OEE, including quality, throughput, downtime. So what was done was, we helped them with was to really apply advanced analytics and to use the advanced analytics software to really combine the data across the value chain, from raw materials to process sensor data, to in the historian, to MES data, contextual data of when specific products were made with specific recipe settings, all the way to what was the final product quality data. To combine that in context, and we applied helped them to apply advanced analytics software to work out what would be the best operating settings on the plant for certain, times when they have certain raw materials for certain products on certain lines that will avoid waste, maximize OEE and quality. And this had significant benefits for the customer. As you could see, they were able to reduce waste significantly. And, in other words, produce exactly the amount that they were planning to with much better quality. And, that obviously had financial benefits, but also reduced customer complaints. So customer satisfaction was much better. And also on the raw material buying side, it even had benefits there, because they could work out that what was the actual ranges, the thresholds of raw material properties which they can still accommodate and produce good quality product. And from that, they could work out that, hey, they can actually afford maybe to buy under certain conditions, slightly cheaper raw materials and still make good quality product if they just set up the plant slightly differently. So it even had raw material savings, and overall it improved OEE by 9%. This was a fantastic result for this customer. Here's another example, very specific company, Fibo. They produce a wall panel manufacturer in Norway. They had the same aspirations. Again, they have invested a lot over the years to automate their process, their manufacturing plant. They had process historian in place, so they were, collecting all the sensor data. They were tracking their raw materials quality data as it comes in from raw material vendors. As they produce it, logging all the sensor data, but they also had an MES system which were facilitating production operations and recipes and product orders from the ERP, all the way to measuring product quality and also logging that product quality data. And again, they wanted to do the same. So in this case, again, we worked with them. We helped them to use analytics software that can easily combine the data from these various systems for analysis and optimization. And from that, within hours, so often very soon you can get first insights, typical improvement insights. But within hours, they gained multiple first improvement insights. Insights like, what combination of raw materials for a given product was, raw material vendors was working best for us? Or what are the optimal raw material quality thresholds beyond which our risk of making bad quality product goes up a lot? So what is this sort of worst quality raw material, so to speak, that we can accommodate in our process? And lastly, they already had a sense what were the critical process variables and set points that they needed to be careful about. But what this highlighted is what were the specific thresholds where these settings in the plant, these process variables, were really starting to affect quality. And for them, this was fantastic and very valuable to help them on their journey to start to optimize their efficiency in the plant. So, how can manufacturers get started on this journey, and what should you be thinking about and giving attention to? So to summarize, so far in this session, I've looked with you, we took a journey and we looked at how manufacturing companies can utilize analytic solutions that are now available and apply it to their MES and other operational data to optimize and improve overall equipment effectiveness, or OEE. And we said the first step is that you must be measuring and calculating and tracking your OEE. You must know what it is. If you don't, the first step is to implement software that can help you calculate and track OEE. That is often part of MES solutions, and that is a great thing. If you don't have a MES, that's foundational, should consider it. But if OEE is your only objective, then there are also other more lightweight solutions that are just focused at calculating and tracking OEE from vendors like GE Digital and others. That's the first step. But then analytics solutions exist that can help you utilize the data from your OEE system, from your MES and other operational systems, to understand why efficiency is low or why it varies, and how you can improve it, and to help you optimize it in the quest for 100% consistent efficiency all the time in all your plants. And we've seen that, globally, 85% is considered world-class, but we know often in industry, manufacturing plants sometimes run as low as 60%. And so what is the value of a 10% improvement? In our experience, we've seen that customers applying analytics to their operational data can achieve up to, and even sometimes more than, 10% improvement in efficiency. And what would that be worth for your manufacturing plant? So, but you can't jump to optimization. The basics must be in place. So you make sure your basic automation in place, your automation systems, SCADA, historians, then your operational systems that just digitize your manufacturing processes, make sure it is orchestrated consistently like your MES systems, facilitate those operations, and calculate and track OEE. Once that is in place, you must think of the next step, which is optimizing OEE with analytics. And the good news is that, out-of-the-box capabilities exist with vendors like GE Digital that can help you do that. And the other really important thing is that you should choose solutions that empower your existing people. So, your existing people in your manufacturing plants, your engineers, your operators, the subject matter experts that really knows your processes, those are the people that should be empowered by simple to use analytic solutions that can utilize your available data and essentially empower them to leverage their domain knowledge, but just empowered by analytics to continuously and quickly apply their domain knowledge, assisted by analytics, to optimize the efficiency of your plants. So empower your people, think optimization once all the foundations are in place, and know that significant gains are possible in optimizing OEE using advanced analytic software. Thank you very much. Mark, I want to thank you and everyone for the opportunity to spend this time together to talk about how manufacturers can utilize advanced analytic software and the significant opportunity that exists to utilize analytic software to optimize overall equipment effectiveness, OEE, in manufacturing plants. Thank you, Mark. Back to you.
Well, thank you, and for the knowledge. And now we have the opportunity to collaborate with our presenters and experts to answer questions from the audience. So type your questions for Cobus and Greg in the Ask a Question box on your screen, and we'll get to as many as time allows. Questions that we don't get to today will be posted online with the archived version of the webcast. Remember to download a certificate of completion and a copy of the presentation by using the Event Resources tab on the left side of your screen. And now on to the questions. So let's see. Have you seen supply chain challenges accelerate the need for or interest in industrial data analytics? Why and how?
So I think I will take that question, Mark. Thank you. The short answer is that I think, the time of optimizing silos is over. I think the operational systems allows us now, and the analytics solutions that I've been talking about allows you to combine data in context across the value chain, from raw materials to final product quality. So that enables the more value chain analysis in context of how to optimize plants. And this tying into the whole supply chain issue, because essentially the world we live in has become more dynamic. And the question is, every plant must run at maximum efficiency. And it's more often needed to switch between products because your supply chain systems may be more frequently assigning maybe different production to different plants using different materials. So it's more important than ever to have the analytic solutions available that can optimize for a given production scenario once that is assigned to a manufacturing plant.
Greg, anything to add there?
No, I think that's good.
Good. Okay. When can we start seeing ROI from implementing this type of solution?
Mark, ROI can be as quickly as, I mentioned, as quickly as hours when you apply the right analytic solutions to your operational data. What I mean by that is, first improvement insights we have seen can sometimes come as quickly as within hours. However, typically rolling out these analytic solutions, can take weeks to months. But I would typically say within months, and definitely within the first year, companies can generate significant improvements, in their OEE and efficiencies.
Very good. The capacity of plants and logistics are designed for peak sessions and after peak season. The volume of orders, which has direct relationship with throughput, drops. What's the best way to benchmark OEE of such plants?
That's a good question.
That was addressed to Greg, but Cobus, if you have some insights,
Greg, please go ahead. Go for it.
Yeah, I think so. So OEE you can manipulate the inputs to it to be variable. So if you're at peak for the summer season, for example, you could have different throughput targets to generate the OEE values. So it is a little bit, it is a little bit of a calculated approach where you kind of want to manipulate it based off of what your targets are for that period of time.
Very good. Does finding the right mix of on-premise or cloud-based analytics vary by industry, organization size, or is it primarily regulatory and criticality and timing, as you discussed?
It will by nature vary somewhat by industry. For example, if you have, imagine you're looking at very distributed operations. Think oil and gas, for example. You may have drilling and distributed places, and essentially a lot of the data or operations of a network. If you have to manage a network, some of those types of situations are more cloud-centric or centralized, so to speak. But then typically in manufacturing, where you have a variety of autonomous manufacturing plants that produces an end-to-end product, complete products, there is a good balance. The metrics which I provided, the considerations around what is critical, what is not, what is more cross-plant enterprise applies more across all the industries, I would say, where you have traditional manufacturing facilities that manufacturing products end-to-end locally, and you have some sort of central functions on an enterprise or headquarter level that just provide services to these plants or help them to schedule production or some centralized services. In those sort of cases, I would say same considerations applies more or less across all of those industries that share those characteristics.
Very good. Do we need TEEP if we are calculating OEE? And perhaps explain what TEP is.
Mark, who was that question addressed to?
That was question 25. It was in the new questions tab.
Greg, do you have anything? Do you have an idea? Do you want to take that one? Otherwise, Mark, we can maybe take it offline and get back with an answer.
Yeah, I think let's answer that after the.
Very good. When you mentioned predicting, does that mean using AI? How do you select the variables that really impact the process?
That's a great question. Yes, it can mean AI. It doesn't necessarily have to mean AI. Analytics software can use appropriate algorithms, which may include AI, to predict elements of OEE. And, typically our approach, a sensible approach, is to keep these things simple. The more complexity you add, the more expensive it is to maintain. But, so yes, it can mean using AI. And how you select the inputs is, analytics software typically help you to process large amounts of data and look across your available variables through typically correlation and other capabilities to identify what are the variables that have the biggest impact on variability in your performance. Another element of that can be, again, like I mentioned, it's important to empower your own people. So your process experts, their domain knowledge, they may already know a lot and have a great idea of what do they suspect are the most important variables. That can be used to some extent for sort of down selection or for selecting potential candidates. But generally, the right analytics software can correlate lots of data to identify the variables with the biggest impact.
Good. How does the tool or the platform help operators or engineers interface with the system to get good information? Frequently, the issue is not lack of data, but more often lack of context, relevant information, such as reasons for downtime, reason codes, editing information that was incorrect, identifying issues that don't make sense, and things like that.
Thank you, Mark. So was that question addressed to someone specifically, or?
18 under the New Questions tab.
Okay. So do you mind repeating the question, please?
Sure. How does the tool or the platform help operators or engineers interface with the system to get good information? Frequently,
Yes,
the issue isn't the lack of data, but more often lack of context.
Yeah, again, I would say, Mark, that the right operational systems, like the right MES systems, the right analytic solutions, are focused on user-friendly and easy-to-use interfaces that enable your operators and your existing people to easily interface with the data for maybe, to understand your OEE via easy-to-use reports of OEE with downtime reasons, etc. Those typically you will find within the OEE software, either MES or the lightweight OEE solutions. And then from the analytics point of view, then easy-to-use analytics software would make it easy for your engineers and operators to really just access the data they want and analyze it to gain quick insight. So it's a great question, but it's really the right tools will enable those sort of easy interactions.
Greg,
Yeah,
you started in at one point. Yeah, go ahead.
Oh, sorry. So I was just going to say, I'd like to add, the tool might drive you to a sort of a generic error that you might have to go and split that out into different error codes or reason codes, but to gain more insight. But if you notice that half of the downtime is caused by a generic error, you need to dig into that number and try to get a little bit more insight into what's driving that.
Very good. So, what data pieces are most often missing in efforts to optimize processes with analytics? Do you see patterns?
I would say, Mark, that the most important thing is the ability to combine data across the value chain in context. And so, for example, if you think about you're producing a product from raw materials, you start with raw materials. Do you know the raw material quality, that the quality and the properties of the raw materials that was used to produce a specific batch or lot or product ID? And then when you produced it, what was the contextual data? That often comes from the MES system, like the recipe that was used, the settings on the machine, the production order, all the operational data. And then while you were producing that product, what was all the sensor values? Those are often recorded in your process historian. And what were the alarms and events that occurred during that production? And then finally, the product that was made, what was its final characteristics, its quality, often contained in final product quality, in LIMS systems, or even in your MES system, or sometimes in your ERP system. So what is important is that you have data across the value chain, from raw materials to final product, and that you combine that in context to provide to tell the full story, to allow the analytics to determine what would be the best settings for given raw materials on a given machine for a given product to produce the best efficiency when you're making that. So what would be missing more often is if any of those pieces are missing, or you don't have the tools to easily combine it in context for analytics.
Very good. Anything to add there, Greg?
No, that's good.
All right, great. We're just about out of time. Thank you very much for the great questions from our audience. And thanks again to our great speakers, Cobus van Heerden and Gregory Dunn, for sharing their time and experience with us in this webcast and Q&A session. I'd also like to extend special thanks to our sponsor, GE Digital, for sponsoring today's event. Now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. Finally, on behalf of Control Engineering and GE Digital, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.